Hi, welcome. Last time in part 2, we had tried to walk through in GDB and try to identify what was happening within the connect script, but I believe that the threading within the Kemu process and Go binaries were not happy with each other, so we had to come up with a part 3 to find out how to bypass this with GDB. As this is becoming a little bit longer part series compared to the other tasks so far, and hopefully the future ones aren't as nearly part heavy. This will be the last part, hopefully, where we finally get to the process of identifying the solution for this challenge. And the way to do so will be going back against what I had said for the previous challenge, or in the previous parts. So for this, the best way to do this is to actually go back to 3, spin this up within the actual Kemu system itself. We're running this as Kemu user, so that's just trying to run a binary like within a user space. But now we're actually going to spin up the whole Kemu environment and run that as is. We're going to do this by copying over this Kemu arch from challenge 3 into challenge 4. Go back to 4. And if we remember within here, there's this README that has these arguments on how to run task 4, which we didn't actually use at all, but we are going to use in task 5. So we're going to copy this command. I would usually do the export stuff, but it doesn't matter too much. So in this directory, we have the SD image, USB image, kernel, BCM, and then Kemu directory. This Kemu directory is important because we need these Kemu IF up and Kemu IF down. Arch64, Kemu Arch64. Go over to this USB image, change this to USB.image. Change SD image to SD.image. Change DTB to this DTB file. And then change this kernel to the kernel image. Operation not permitted. I believe that is because these guys are not... Nope, those are executable. Let's run this as sudo then. Sudo. Should get it spinning up. It's going to take a little bit to spin up because every instance that you try to run it is going to try to decrypt the share that we had found the password for in task 4, but the problem is that we don't have the password set within this share or within this system, so it's always going to fail. But even though it fails, it still takes a long time for it to try to decrypt. If it didn't fail, it would probably try to run up the agent binary that we had found right away, but we don't really want that. We want this to run, just start running ourselves. We want to be able to run the stuff ourselves. So while that's going, we need to get a couple stuff working first. So our process is we want to be able to use GDB within this, but since this binary itself is, or this environment is going to be raw, we're going to try and find a binary ourselves. So GDB server arch64, let's try and find stat compiled. Usually you can find one already compiled and hosted somewhere online. Let's just grab the raw version. Let's toss this in 5. Wget this file GDB server. Perfect. I'm going to move that to GDB server. Just get rid of this. Oops, get rid of the name. And what we're going to do is we're going to move this binary onto this Kemu instance. So now we can run GDB server and then just communicate cross boundaries. And while they're both running, while this will be running similar to in Kemu as our user space application, the fact that this is running in system will allow the threads to handle better, so we should be able to walk through it more seamlessly. We will have to deal with GDB server issues that just arise, but nothing too bad should happen. So now we can see that we're in. If we check out agent, we should see that it's empty. At some point, we need to actually mount it ourselves. So if we go to etc initd rcs, we do need to run this, or not that. That's going to run mount part and pry or an opt. Count opt mount part. We're going to want to run this. The encrypted partition should be stored at opt part as well. Oh, I didn't like that. Let's see if I can get the line wrap to not be so horrendous. Okay, get you, there we go. Sad there's still line wrap on here, but that's all right. So get rid of this, go opt part encrypted. We know what the password is. For this instance, it was nasty plea 99E. It should still take another minute because since it's running an emulated instance, it's going to be much slower than the localized version that was running within the crypt setup last time. But we do need to have this mounted at some point first to actually be able to run stuff. I should have put this in the background before I ran it. That would have made this easier because then I could have started working on moving the GDB server binary over. But we'll just have to wait for that. So if we check our IF config, we now have this new tap0 interface, and we should be able to hit the box. If we remember, it should be at 255.254, and we're able to get a reply. That was set within the initd. It hard codes its IP address, so it should always be at that location. This is almost done. So what we can do is just set up a netcat listener on port. Probably set up the listener on that side, actually. It doesn't matter too much, just how big is this binary? 58,000 or 586,000 bytes. It's not too large. Is it stripped? No, it might be. It is stripped. So that's kind of as low as we can get. Problem is it's statically linked, so it's going to be a little bit bigger than usual. This sure is taking its sweet time to mount, because the problem is GDB server will also take a little bit to move over. There we go, that's finally there. We can mount it now. So mount this to agent. Check out agent and see that we now have our files. Perfect. So luckily this system came with netcat, which I think is usually default on a lot of BusyBox systems. So I'm actually going to set this to listening mode on port 1234 and just store this into GDB server. You want to make sure you don't put it into agent, as agent is a mounted point. It's not going to have the space, because I think it's statically set to whatever space is left within part encrypt. So setting it to the root directory temp somewhere else, if you do it this way, is a better method. So we can just send this over by sending this to 10.101.255.254 and sending in GDB server. Oops, I need to set this to 1234. The problem is I'm not really sure how long this should take. It just kind of needs to go until it's done. So a way we could do that is, usually you could probably use, might be able to use TCP dump on, just in general, sudo, let's do TCP dump on interface tap0. This should tell us what data is being sent through. Listening on tap0, doesn't look like anything's being sent anymore, so maybe it's done. Let's kill it and find out. GB server, it looks like it has all the data. Perfect, didn't take nearly as long as I thought. Sometimes it takes a couple minutes to send all the data, depending on the size of the binary. So if we just chmod GDB server, we should be able to run it. Perfect. So GDB server does is it allows you to send, it's pretty much like the QEMU GB Connect where we did target remote, but now we're actually going to do it over the socket, and in this case it's going to be the tap0 socket, or not socket, interface. So we should be able to go to agent. We still need, bzip should be on here. We still need a YAML of some sort. So let's echo foo. If we check out our last one, change to agent cat backup, just foo bar. So echo foo bar into back.yaml. Oops, that probably didn't work because I didn't use quotes. Oh, it did. Sweet. The new line should be fine. Should be in there. Next, we need to, let's just bzip this one. And then if we ran dropper, that should work, but we're going to run GDB server instead. So the way we can do this is we we should be able to specify a way to communicate and then the program and any args. So I think if I remember this correctly, we can do GDB server, going to listen on the 10.10.101.255.254 interface on port 1234. I just use that as default. And then we're going to use dropper and drop backup.yaml.bz. Now this should wait for our GDB multi-arch to connect, which I think I just did in that terminal, so just need to spin up a new one. Dropper, target, remote, 1234. Nope, it's not a localhost. 10.101.255.254 on 1234. And look at that, we're connected again. So not nearly as, it only took about 10 minutes to set that up, but thought it'd be a little bit more hassly. So if we go back to our Ghidra setup, okay, I thought I closed Firefox at first. We want to set a breakpoint, because we lost our breakpoints, at exfil connect, see if we can even hit that at 381264. If this doesn't work, we'll have to go through a different method of trying to find this. Continue. Looks like we hit the connecting to server. It actually hit this time. Where'd my GB go? And we hit the breakpoint. Perfect. We actually hit it. Not that I'm surprised. I knew this would work the entire time. So, walking through exfil connect. We're going to start going down to these Mongo connect parameters. Another one that might be worth trying to set a breakpoint at is maybe just connect in general. Do we have socket? Okay, we don't have any symbols, so we can't really do that. It looks like it's trying to use a server URL, a database, and a database collection, which right now are empty, so maybe those were read in from our log file. If they were read from our log file, we might have a little bit more problem because we don't have a log file at the moment, but we'll just keep walking through it. Don't need that. Let's keep this one open on the side just in case any data is printed there. And we're going to start stepping through. The stepping through process is going to be a little bit slower since this is now going through a socket. Blah, blah, blah. No idea what it's really doing. We're just going to step through until we maybe see something that's of use. Runtime, df0, that's probably nothing, so we're going to step over that. What we really want to do is step all the way down probably to this Mongo connect function. Mongo options could also be something of use. That looks like it's zeroing out a lot of data. Both of these should happen relatively near the top, so if we just keep walking down, it should be fine. So if we continue stepping through, step, 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 step. GDB, you weren't supposed to crash. Well, GB server will reopen. Remote site has terminated connection. So hopefully it just stayed at our location. Oh, not that one. 10.101.255.254. That does in fact look like a problem. Is this from a Jeff problem or is this a GDB problem? We'll go to the GDB init, comment this out, try running this again. Could just be the vast differences. I'm using 13.2 here versus 8 something. Oh, target, remote, 10.101.255.254, on port 1234. Looks like it's Jeff is doing something. I kind of want to know if our server URL is actually modified at all. So I might do a backtrace. That's not going to print it. That's very nice. Can I do print server URL? Optimized out. Okay, let's look at the $RIP. Where are we? Oh, there's no RIP. It's a program counter. So it looks like we're 2 or one instruction away from the branch. So it's step. And then we're going to do IR to dump the registers, see what kind of parameters are sent in. We have X0. If we look here, what it's expecting, we could even look up to see what Mongo options is apply URI is even supposed to do. Wouldn't be a bad idea, as these are just the common Go binary handles. So Go MongoDB apply URI. So if we do apply URI, see what it's supposed to do. Pass apply URI, which returns a new client option instance. So is there, if I do next, where's that one at? There it is. So it looks like options client, apply URI, set server API options. So this one probably isn't happening, but this apply URI I did on options client. Yep, default HTTP client. So it looks like we're just setting some options. It might just be passing in the default structure object or URI it says. And URI should be the connection string. So if it's in memory, there's a good chance it would be right here. Not holding my breath though. At print, let's do x/x at $x0. Yep, empty string. So that's still probably the empty string from what we sent in, which is fine. We can just continue through. I didn't want to do step. That wasn't my fault. Let's come up here to set a breakpoint. At 4. Continue. I'm now going to detach. I wonder if there's a way to GDB load init while running. I was going to say, is there a way to load the init back up while we're already running, so then we don't have to close it. So I kind of want to get the Jeff handles back in because it makes it look so much nicer, even though the Jeff handles are crashing us. Let's see, where are we? x/i $program counter. Step through a little bit. See where we actually care about being. We care about the connect, so we're going to set a breakpoint down there. Let's check out the registers. Looks like we have 3 of them this time. x/s. It looks like a context. Runtime base 0. And then nothing. Which once again don't look too helpful. That looks like a string of some sort. Check out to see what that is in CyberChef, but something. Nothing to use there. So this process is not going to work. Looks like we're missing either a piece of information, which is in the log file, or we're missing some kind of just information in general. Let me do a quick scan through memory. So what's interesting is that, just while looking through memory, is that there's this big block of just raw data right here that's not being used. So usually there'd be, oh, maybe are they all just, they're not all just strings. They could just be strings from the actual binary itself, but it appears that there's some kind of, oh, there's also stuff down here at the bottom. So it looks like there's stuff at the bottom that's unallocated or unused. Is there any reference to that? Doesn't appear to be. I'm wondering what the best way to actually, so this data down here looks interesting because it's one not used, even says it's unallocated. It doesn't look like there's any references to it besides within the ELF header itself, which makes me wonder on the correct way to go about figuring this out. So after going through all this walkthrough, we've come to the conclusion that we're missing either the log file or we're missing some kind of data. So maybe with that in mind, we go about trying to look for data that we might be missing. We have another file that we just haven't looked at yet. Dropper has so far come up nothing. Not nothing, but we know what happens, but it just hasn't happened yet, or we haven't come across anything. If we just try to run dropper, we can see what happens, see if anything interesting occurs. I don't think anything will. It just says failed to connect, parsing URL schema must be MongoDB. So it fails to connect because we don't offer it a valid MongoDB instance, which makes sense since we don't have a valid MongoDB instance set up or within the log file. So there's a good chance that the log file itself has some kind of MongoDB instance in it. So a handy way is we'll just grep everything. We're looking for dropper.yaml. grep-tech r dropper.yaml. Looks like the config is the only spot that actually carries it. We could also check here. Temp, there's nothing in temp. There's nothing at all in temp. So it's not there yet. If it does get created, it gets created at a different time. So it already expects the YAML file to exist. I don't think any of the other scripts contain this dropper information, but looking through maybe the data on these other files, we could come across something interesting. We could look it up at Daggle client, but I'm going to save that for a different challenge, as that's spoiler wise, it's not for this challenge. But what was interesting was when you take note of, was this extra data down here at the bottom of this binary, and that it has a characteristic BZ header. If we remember back, we've been working with BZ data so far with our bzip. So if we look at our back.yaml, whoops. If we look at our log.yaml, whoops, don't do that. Don't want bat, I want cat. We have this bzh9, which looks very similar to bzh9 here. And it turns out that this actually is going to be another BZ share stored within the binary. And if we're looking to extract binary data from a process or just a file, we can use binwalk. So if we do binwalk on dropper, we can step through and notice that at some point there's bzip2 compressed data at the end. So if we extract it, should come up with a new file, and in this file looks to be a database collection. So it looks like this bzip data was actually a new database, and it appears to have the database collection, URL, directory. So this probably was the actual runtime process config file. I'm not really sure why it was concatenated to the end of this binary. Maybe there's if we actually look at dropper in XXD, a little bit bigger than I was anticipating, but I'm guessing it's at the very end. Any day now. I didn't see any processes while reverse engineering that say that it's going to append the log file to the end. But at some point, the binary itself has it's right here. I think. Yep, BZ. It's appended right there. So maybe there was a hint somewhere or some kind of reference saying it's going to append it to the end of the binary before the binary is ran or before it's saved. I don't think there were any references to that because we already tried grabbing the dropper YAML file from everything and it wasn't identified anywhere. So with that in mind, it could be just the binary itself. Doesn't make too much sense if that happens. So if we look in the actual binary. So my original solution when I found this was I was just randomly binwalking the file, and I came across that there's a bzip share, and I came across the drop. So I'm not quite sure on the correct process of going through it. But that might be the cheat method that people mention in the Discord server. But if we actually check let's go back to main. If we go into the read config, read file, it might just append whatever was in the config to the end of the file. I don't think it does because it never writes to the file, I don't think. we can check this by checking our secondary one. If we grab tail, I'm just going to vim dropper because we used a new back.yaml. Well, we used a new back.yaml with this one, but this one never actually ran. So if we check out, oh, don't have vim, bi dropper, go to the very end. If we search for bz, there's one header. I like it to go to the very end and look backwards. I feel like that's too much data. Should just be sitting around here, but it didn't find it. Go down as far as we can. Oh, there's a lot of BZs, that makes sense. So this looks like the very last one. It's only one of them. So I'm not really sure how it gets appended. I was under the impression that maybe somewhere after it gets loaded, it appends it back to itself, just for safekeeping, which doesn't make too much sense. But with that in mind, some of these challenges are just kind of dig until you find something. But with that, if we go into the dropper, we can inspect this file. This is probably what the YAML looked like before it was bzipped. Looks like we are a collection of files, a database of the snapshot, URL of a MongoDB instance, which we were trying to fake, but we didn't have, and then a directory for temp upload. And then we can take this IP, as that appears to be what the challenge was asking for. Close these. Come down here, enter the IP address, don't guess. And if we press enter or submit, connection died again. Come back down here. Reset. We can see that that was the correct solution for task 5. Thanks for watching. I know this got a little bit out of hand with the jumping back and forth in different parts, but hopefully you learned something new in a different process on how to reverse engineer or jump into a binary. In the next task, we'll be looking at the MongoDB instance and trying to follow that. And then in the future ones, we'll be jumping back into the reverse engineering. So everything we've done in the reverse engineering so far will come in handy. A little bit of the dropper will still be used in the future, I believe. I need to think if the dropper is used again. I think it is, because I think we will use it. It doesn't need to be used, but it makes it slightly easier if you use it again, I believe. Down here, it tries to grab a server address. Might be wrong. But yeah. You may be thinking, what's the point of this blah, 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 this database session itself? Close. Let's bring that back before I forget. Close that one. So right here in our YAML file, we have a collection, a database, a URL, and a directory. When there's also a chance that, if we remember back in the original agent file, that when it runs it with, if we go to the upload thread, database collection URL. So it could also just been through the environment variable arguments, because the environment variable arguments are also read in. Up in read config, read environment variables. We didn't look too much into that, mostly because it wasn't really needed, but there's a chance that those environment variables could lead you onto possibly that the values at the end. I don't think it would. But if you have the environment variables, why do you even need the config? So it's kind of wishy-washy on which one's actually used. I think we'll see that I'm not sure if we actually use dropper again. I don't think dropper's needed. No, because dropper just uploads to the database, yeah. So yeah, so all we need from this is going to be this collection, database, and URL, and then we'll be able to work on the next challenge. Hopefully you learned something like I'd said, and enjoyed the videos. Thanks for watching.